Okay, we are going to go ahead and begin our final exam review for Survey of Contemporary Mathematics. I'm just pulling some sample questions from our end of the book review. So I just want to go through several examples that we have learned throughout our time together and just kind of refresh your memory on some of these chapters. Number one says to simplify. We're going to be performing the order of operations. Remember, that's PEMDAS. Please excuse my dear Aunt Sally. You will start with any grouping symbols and do those parentheses first. Next would be exponents. Then we multiply or divide from left to right, whichever comes first. And last, we'll add or subtract from left to right, whichever comes first. So here I've got my grouping symbols. 5 minus 3 is 2. Then we're going to do the exponents. 3 squared is 3 times itself, so that would be 9. 2 squared is 2 times itself is 4. Okay, we've got multiplication and division. We're going to work left to right. 9 times 4 is 36, and 36 divided by 3 would be 12. 12 plus 4 equals 16. So that'll be the answer to that problem after we simplify using the ordered operations. Number 2 is to find the least common multiple between a set of numbers. The least common multiple is the smallest number that they will divide into. There's a couple of ways to do this. You can take your numbers and list all the multiples: 16 times 1, 16 times 2, 16 times 3, and do that for several numbers. This could go on forever. 12 times 1, 12 times 2, 12 times 3, 12 times 4. Here we're seeing a common multiple. We need to just see, does 9 go into that? 9 times 1, 9 times 2, 9 times 3, 9 times 4. Here we have a common multiple, but it's not a common multiple between all three. 9 times 5. You can see that this could go on for a while. We could continue with this method to find that least common multiple, and you will if you continue that out. I just want to show you a method that may be quicker when you've got these numbers. And to do that, that was how we found the prime factorization. 9 is 3 times 3. 12 is 4 times 3, which is 2 times 2 times 3. And 16 was 4 times 4, which is 2 times 2 times 2 times 2. So if you use the prime factorization method, you need the greatest amount of each number. So like here I have 2 3s and 1 3. So I'm going to take that group of 2. Here I have 2 2s and 4 2s. So I'm going to take that group of 4 2s. All right, and so whatever this simplifies to be, that will be my least common multiple. 3 squared is 9, and 2 to the 4th power is 16. And if I multiply 9 times 16, that will equal 144, which is my least common multiple. If I continued with the multiples, it would have taken me just a little while till I got to that really big number there. So this method will work by listing all the multiples until you find the least common multiple between all of your numbers, or you can find the prime factorization and then take the largest group of each number. Okay, now I want to look at the greatest common factor because that's different, but the GCF and the LCM are often confused. The greatest common factor is the largest number that will divide evenly into each of our numbers. So you might be able to figure that mentally, but by also doing a factor tree and finding that prime factorization, this is another way to find that. So here I'm going to factor that 16 out to 4 2s again. 44 is 4 times 11, which is 2 times 2 times 11. So with this method, the greatest common factor is the greatest amount of factors that they have in common. Each of them have at least 2 2s. So the GCF here would be 4. 4 is the largest number that divides evenly into 16 and 44. Don't get that confused with the least common multiple. Okay, don't forget when we are adding and subtracting with fractions that we have to get a common denominator. So that's what we're going to do on number 4. What is the least common multiple of my denominators? 8, 6, and 5. So I could do the same kind of method that I did here in number 2 to find that. The least common multiple between these will be 120. I know that 8 times 15 is 120, so I have to multiply 3 times 15 as well. That would be 45. 6 times 20 is 120, so I have to multiply that numerator by that same amount. 5 times 20 is 100. 5 times 24 is 120, so 1 times 24 would be 24 to get equivalent fractions with a common denominator. When we add and subtract fractions, the denominator does not change. So I'm going to add 45 plus 100 plus 24, and I'll get 169. Now I need to convert that into a mixed number unless the problem asks you to leave it as an improper fraction. So to convert an improper fraction to a mixed number, I divide the numerator by the denominator. 120 will go into 169 one time, and that will leave a remainder of 49. So I would write that as 1 and 49 over 120. Of course, you want to simplify your answer as far as you can, but in this case, this is the most simplified answer. Okay. Don't forget what some of our words that we use in math mean. Sum is the answer to an addition problem. Difference is the answer to a subtraction problem. Product means to multiply, and quotient involves division. So know those words. This problem is asking me to multiply these mixed numbers. And in order to multiply, we do not have to have a common denominator, but we must turn any mixed numbers into improper fractions. So I'll do that by multiplying 8 times 3, that's 24, and then add the numerator. So 8 times 3 plus 5. 8 times 3 is 24, plus 5 is 29. And we keep the same denominator. 7 times 1 is 7, plus 5 equals 12. Okay, before we multiply, if we can reduce anything, I want to do that just to help make the multiplication a little easier. I know that 8 and 12 are both divisible by 4. 12 divided by 4 is 3. I won't be able to reduce 29 and 7, so that means now I'm going to multiply 29 times 3. That'll give me 87, and 2 times 7 is 14. So I will simplify this into a mixed number unless it asks me to leave it as an improper fraction. This would be equal to 6 and 3/14. All right, so I'm going to work this division problem very similar to the way I worked the multiplication problems. First thing I'm going to do is convert my mixed numbers into improper fractions. So 3 times 1 plus 2, that is 5/3. 4 times 3 is 12, plus 3 is 15. When we divide with fractions, instead of dividing with those fractions, we're going to multiply by the reciprocal. I call that leave, change, and flip. You're going to leave that first fraction alone, change division to multiplication, and flip that second fraction. We are multiplying by its reciprocal. If I can reduce anything, I'm going to do that. 5 will go into itself 1 time and into 15 3 times. So if I multiply the numerators, I get 4. If I multiply the denominators, I get 9. This is a proper fraction. It can't be reduced any further. So that's my final answer. All right, and number 7, this is another problem that involves order of operations. This problem contains fractions, so I'm just going to continue to go through, do parentheses, exponents, any multiplication or division, and then I'll add or subtract. With fraction, you've got to remember all your fraction rules. In order to add fractions, I do have to get a common denominator, and the common denominator between 4 and 3 is 12. If 4 times 3 is 12, then 3 times 3 would be 9. We've got to get that equivalent fraction. If 3 times 4 is 12, then 1 times 4 would be 4. 9 plus 4 is 13/12. I'm going to leave that improper for right now as I work through this problem. All right, to square a fraction, you simply square the top and you square the bottom. So 2 squared is 4, 3 squared is 9. So as I continue through my problem, we're going to do division. So once again, I have to leave, change, and flip. Multiply by the reciprocal instead. 9 and 12 are both divisible by 3, so I can simplify a little bit there. That will equal 16 over 39. And don't forget we've got this minus 1/3 out to the side. So before I can do this math, I've got to find a common denominator. 3 will actually go into 39 13 times. So I need to get that equivalent fraction. Multiply the top and bottom by 13. Now that these have a common denominator, I will subtract the numerators and leave the denominator the same. 3 over 39 will reduce. Both are divisible by 3. That will end up being 1 over 13. Number 8 asks me to convert 45 hundredths to a fraction in simplest form. So 0.45, we call that sometimes, but this is correctly read 45 hundredths because the 5 is in the hundredths place. So if I read that properly, that helps me to know how to set that up as a fraction. 45 over 100, both the numerator and the denominator are divisible by 5, so I can reduce that down to 9 over 20. Number 9, it says to write 323.4 miles on 13.2 gallons of gas as a unit rate. Remember, unit rate wants to know the amount per one item. So I want to know how many miles can we go on 1 gallon of gas. So to find the answer to that, I will divide the number of miles by the number of gallons that I'm given. Okay, so 323.4 divided by 13.2 is equivalent to 24.5 miles per gallon. Okay. That's how far that vehicle can travel on 1 gallon of gas. That's the unit rate. Number 10 asks me to solve the proportion and round my answer to the nearest tenth. Okay, remember, there's more than one way to solve the proportion, but cross products always works. So I can multiply across 35 times n will equal 12 times 160. 12 times 160 is 1,920. And then we will divide by the number in front of the variable. So n will equal, I'm going to carry that out with my calculator a couple of places here. Okay, this actually goes on a lot further, but it asks me to round to the nearest tenth place. So the nearest tenth place is this number directly behind the decimal, but I have to look at the number behind that. If it's 5 or more, we bump up the score. If it's 4 or less, let it rest. So being 5 or more, that's going to round up to 54.9, and that will be the answer to this problem. So be very careful to pay attention to how your problem might ask you to round, review those decimal placements so you understand which location that is. Tenths, hundredths, thousandths, and then it continues on. Number 11 says to convert this percent into a fraction. Normally with a regular number, I could just move that decimal over 2 spaces. That being 1/2, I could write this as 12.5%. Remember, percent means per 100, so dividing by 100 just moves that decimal backwards 2 spaces, so that would be 0.125. But what if that wasn't a number that I could write as a terminating decimal? Remember, I could even put that fraction over 100. We would need to convert this into an improper fraction. 2 times 12 over 1 is 25 over 2. And I could put that 100 over 1. This is what we call a complex fraction because I have a fraction inside of a fraction. And the way we solve those is by multiplying the outside numbers together and the inside numbers together. Okay. How many quarters are in $2? There's 4 quarters in $1, so there would be 8 quarters in $200. So this will actually simplify to be 1 over 8. Okay. So, this would be a simple way to convert that into a decimal, which is correct, but I had to convert that into a fraction. So this is that fraction equivalent. So that's an alternate way to do that. I stopped too short here, but this is tenths, hundredths, thousandths. That would be 125 over 1,000, and that will reduce down to 1 over 8. So just 2 different ways to work that kind of problem. So number 12, given that decimal and trying to convert that to a percent, I would simply just multiply that by 100, which shifts that decimal over 2 spaces, and that would be 135%. To convert this fraction to a percent, there's a couple of ways you can do that, but we can also multiply that fraction by 100%. That is 500 over 4. And if I divide that out, that would end up being 125%. Okay, so to turn a fraction or a decimal into a percent, we multiply by 100. If I'm turning a decimal or a percentage into a fraction or a decimal, I would divide by 100. All right, number 14 says to find 120% of 30. Just remember some of our words. Is means equals, and of means to multiply as we work through these algebra statements here. So what is 120% of 30? That means I'm multiplying 30 times 120%. I need to first convert that into a fraction or a decimal. I can get a decimal by backing that up 2 spaces. So 1.20 times 30, if I multiply that together, that will equal 36. Okay. 12 is what percent of 9? So this is the same as 9W equals 12. Now keep in mind, I want my answer in a percent, but I'm going to just solve this out like a regular equation. 12 divided by 9 is 1.3 with a Repetin bar. Okay, that's like just that 3 is continuously going out. If I multiply that by 100, that will shift that decimal over 2 spaces. So that would actually be the same as 133 1/3%. Or if it allows you to write that as a repeating decimal, you could write 133.3 with a Repetin bar percent. If you did this long division, you would recognize that Repetin as well. Because that would be 1 3/9, and if you that would be the same as 1 1/3, times 100. That's what's going to shift that over. You might want to multiply by 100 first so that you can divide 1200 by 9, and then you can just continue to work that out. That would go in 3 times, another 3, and then we would see that repeating part right there. So that would give us 133 1/3% if you did that by hand. Okay. All right, number 16. 42 is 60% of what number? So I'm going to turn that into a decimal or a fraction. 42 is 0.60W. So I'm going to divide by 0.60 or 0.6. And that would equal 70. Notice this one just asks what number. If it asks what fraction, what decimal, what percent, make sure you give your answer in an appropriate format. Number 17 is converting 1 2/3 feet into inches. You might want to look over your units of measure conversions, but we know that 1 foot equals 12 inches. So 1 2/3 feet can be multiplied by 12 to find out how many inches that will be. Once again, I've got to convert this into an improper fraction. 3 plus 2, that's 5/3 times 12 over 1. 3 goes into 12 4 times, and 5 times 4 is 20. Don't forget your label for these problems. Make sure you label every question that would require one. All right, number 18, subtract 3 feet 2 inches by 1 foot 10 inches. So what I'm going to do is line up those units of measure. Okay. We're going to start on this right-hand side, but I can't subtract this the way I would a normal number. I'm not going to like borrow from the 3 and then make that into a 12. That's not how that works. But I will borrow 1 foot and add that foot back as 12 inches. So 12 plus the 2 I already have makes 14. And 14 minus 10 is 4. 1 foot minus 2 feet minus 1 foot is 1 foot. So that answer would be 1 foot 4 inches. Remember, you can check by adding up to see if we get what we started with. Number 19 asked me to convert 40 ounces into pounds. We know that 1 pound is equivalent to 16 ounces. So if I want to find out how many pounds 40 ounces is, I will divide that by 16. 40 divided by 16 is 2.5 pounds, 2.5 pounds. Remember, sum means to add, so we're going to add these by just combining the like units. 3 pounds and 2 pounds make 5 pounds. 12 ounces and 10 ounces is equivalent to 22 ounces. Now, I do want to put this in the most simplified answer. Since there are 16 ounces in a pound, I can take out 16 ounces and add that as a pound. So that would be 6 pounds and 6 ounces. That would be the most simplified answer and the correct answer for number 20. Number 21 asked me to convert 18 pints to gallons. Well, we need to remember that 1 gallon is equivalent to 8 pints. Okay, so if I have 18 pints, I can divide 18 by 8, and that will be 2.25 gallons, or you could write that as 2 1/4 gallons. Make sure you give your correct label on that problem as well. All right, number 22 asks me to divide 5 gallons and 1 quart by 3. Okay, well, 3 will go into 5 one time, and that's 2. But I'm going to convert 2 into quarts. There are 4 quarts in 1 gallon, so 2 gallons would have 8 quarts. And if I add that with the 1, that would be 9, and 3 goes into 9 3 times. So that answer would be 1 gallon and 3 quarts. Okay, you could check that back by multiplying and then simplifying to the best answer, which would give you 5 gallons and 1 quart back. Number 23 says to convert 2.48 meters into centimeters. Well, if we look back at our information, we know that 1 meter is equivalent to 100 centimeters. So if I have 2.48 hundredths of a meter, I can multiply that times 100, and that will tell me how many centimeters that I'm going to have, which is 240 centimeters. I'm kind of really showing an abbreviated way to do this, but you may want to look back through the book's examples and really just zone in on the unit multipliers. this is the unit multiplier I'm using. And the way I get to use that is by, canceling out that unit of measure that I have. Okay, so see how that meters cancels, and that's only leaving centimeters. So this is why I'm multiplying there. A lot of you will do this mentally rather than showing this step right here, but this unit multiplier is what allows me to do the conversion. Remember, that unit multiplier is just another fraction equivalent to 1. Number 24 says, how much does it cost to run a 2400 watt air conditioner for 6 hours at 8 cents per kilowatt hour? Round to the nearest cent. Please pay close attention to the unit of measure they're giving you and the measure that the question is asking of you. Here we have watt, and here we want kilowatt. So 1 kilowatt is 1,000 watts. So if I divide 2400 by 1,000, that will equal 2.4 kilowatts. And I'm running this for 6 hours. Okay, so I'm going to multiply by 6, and 8 cents per hour. So if I do all that multiplication right there, I'm going to get a decimal. Okay, but this is a money problem, and I have to round to the nearest cent, which is the hundredths place. So this thousandths place is 5 or less, so we're going to let it rest. So my answer would actually be $1.15. So make sure you round correctly. The nearest cent will go out to the hundredths place. Number 25 is asking me to change my decimal into scientific notation. What I'm going to do is shift my decimal over until I get a number between 1 and 10. Okay, so that would be 6.79. It's always times 10 to some power. So how many spots did we move? 1, 2, 3, 4, 5, 6, 7. Count again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that was 8. And because this was a really small decimal, that's going to be a negative exponent. If this had been 679 million and we were putting it in scientific notation, that would have been a positive exponent. Let me double check one more time. So 1, 2, 3, 4, 5, 6, 7, 8 spots that was moved to create 6.79 times 10 to the negative 8 power. Your scientific notation always has some number between 1 and 10 times 10 to a power. Number 26 asks us to find the volume of a box with the given length, width, and height. The formula for volume is length times width times height. So I'm simply going to take 20 centimeters and multiply it by 12 centimeters and 5 centimeters. Length times width times height. And when I multiply those together, I will get 1,200, and I will write that label as cubic centimeters. Centimeter times centimeter times centimeter is cubic centimeters. Area is square units, volume is cubic units. Make sure you're careful with that label on your test. All right, so adding positive and negative numbers. So I'm adding here -2 plus 8 is a positive 6. Different signs subtract. Take the sign of the higher number. So 8 minus 2 is 6. 8 is bigger, so my answer is positive. All right, so then we have 6 plus a -10. All right, these signs are different, so we're going to subtract and take the sign of the higher number. 10 is bigger than 6. 10 is negative, so my answer is negative. Just imagine if you're at positive 6 and then you shift -10 units to the left, you're going to get a negative value. When we subtract integers, what we're going to do is add the opposite, okay? We're going to, I call that leave, change, opposite. You're going to leave the first number alone, change subtraction to addition, and do the opposite sign of that next number. This creates a positive 15. So I go back to the same rules I used in number 27. Different signs. So we subtract those numbers. 30 minus 15 is 15. Take the sign of the higher number. 30 is bigger. It's negative. So my answer will be negative. Sometimes I like to relate positives and negatives with money. I think you understand that better. If you owed someone $30 and then you paid them $15 back, you would still owe them $15. So think of a debt as a negative number, and being in the positive or making a credit is a positive number, and that may help you as you relate those kinds of problems to money. Number 29 says to simplify. We're not trying to solve for x. This is not an equation. There's no equal sign in this problem. We are just simplifying, combining like terms. I will have to begin with the distributive property because we have to multiply. Inside that parentheses, there's nothing that I could subtract, but I can multiply anything together. So that's 2x minus 3x plus 12. Make sure you distribute that -3 times everything inside that parentheses. Now we want to go through and combine like terms. These terms have an x. 2x minus 3x would be -1x. And 12 plus 5 is a positive 17. Please pay close attention to your positive and negative signs. That was a big deal in this last apply that I checked. So make sure that you, when you add or subtract, that you give the correct sign with each term in your answer. All right, number 30, we are solving this problem. Notice this is an equation. All right, so we're solving for x. This is 2/3 times something equals -12. When we are multiplying by a fraction, I would have to divide by that number to solve for x. But when we divide with fractions, I have to multiply by the reciprocal. So that's the step I'm going to take here. Multiplying by that reciprocal totally cancels that out, and you're left with 1x. That's what we want. But whatever we do to one side of the problem, you have to do to the other. And we can reduce this to, goes into 12 6 times. 6 times 3 is 18, but pay attention to that negative there. A negative times a positive will create a negative answer. So my answer is x equals -18. Number 31, I'm solving this equation. It's a two-step problem. I want to isolate x. Right now, x is being multiplied by 3, subtracted by 5, and then we're getting the result of 10. So as I work backwards, I'm going to add 5 to cancel that out. We're trying to isolate that variable. But whatever I do to one side, I have to do to the other. So 3x equals 15. And if I undo multiplication with division, I will get x equals 5. Don't forget, you can check all your equations by substituting your answer back into the problem. If I plug 5 in for x, I get 3 times 5 is 15, minus 5 does equal 10. So it will check out. On number 32, we have a variable on both sides of our equation. I want to start off by getting those variables on a side together. And I encourage you to move the one with the smaller coefficient. Okay, we've got -3x and +1x. Negatives are always smaller than positives. So I'm going to move the 3x to the other side of the equation by canceling that out. If I add 3x, that makes 0. And that leaves 8 equals 4x plus 4. Now this equation is a lot like number 31. I'm going to isolate the x by first subtracting 4 on both sides. Let me carry that on up here. So 8 minus 4 is 4. 4x equals 4. If I divide by the number in front of the variable, I will get x equals 1. Okay. We can check that by substituting 1 into both sides of the equation. 3 times 1 is 3. 8 minus 3 is 5. 1 plus 4 is 5. So since both sides equal 5, this is the true answer. All right, number 33. On the basis of a pre-election survey, it is estimated that 5 out of 8 eligible voters will vote in an election. How many people will vote in an election with 102,000 eligible voters? When I read this problem, I immediately think proportion because I'm comparing two things. I see that 5 out of 8 voters will actually vote in that election. So 5 will vote out of a total of 8. So how many will vote out of a total of 102,000? I can set up that proportion, keeping my sides proportional. How many vote out of a total? How many are going to vote out of a total of eligible voters? We can solve a proportion by cross multiplying. 8 times x will equal 5 times 102,000. That will be 510,000. And then I can solve this equation by dividing by x. So that would be 63,750 people. That's how many we could expect if it worked at the same rate. It's a prediction. It's not a way that we can know for sure. Number 34, this month the company is paying its stockholders a dividend of $1.60 per share. This amount is 80% of the dividend per share 1 year ago. So what is the dividend per share a year ago? So I'm hearing the words is and of. So this number is 80% of that dividend per share. That's what I'm missing. That's the unknown right there, that dividend per share. So $1.60 is 80% of, choose your variable. I picked D. I'm going to convert my percent to a decimal. That will be 0.80. I will divide both sides by 8/10. And so that dividend per share would end up being 2, which would represent $2. So 1 year ago, the dividend per share was $2. Okay, it's 80% this year, which represents $1.60. You could check that because 80% times $2 equals $1.60. Number 35, a sales executive received commissions for the given amount during a 4-month period. Find the mean monthly income from commissions for the 4 months. Let me just kind of review these measures of central tendency with you. Mean is the average. We're going to add all these numbers and divide by how many there are. Median is the number in the middle when they're written in order. The mode is the number that occurs most often, and the range is the largest number minus the smallest number. So this problem asks for the mean. I want to know the average. So we're going to add these 4 numbers together. That would end up being 15,176, but we have to divide it by how many there are. Those are 4 numbers. So if I divide by 4, we get 3,794. Number 36, a contractor borrows $120,000 for 9 months at an annual interest rate of 8%. What is the simple interest due on the loan? I really encourage you to go back and look at those formulas from this chapter, but simple interest is calculated by interest equals principal times rate times time. And the thing about time is it has to be given in years, and they've given us months. So my interest is the principal times the rate, which is 8%, and I'm going to turn that into a decimal. Remember, we divide it by 100, shift that decimal back 2 spaces, times time, and since it's given in months, I will put that over 12. Okay, so as I multiply all that together, I will get an answer of 7,200 in simple interest. All right, number 37 asks us if 2 dice are tossed, what is the probability that the sum of the dots on the upward faces is divisible by 3? I want to encourage you to look back in chapter 7 at the chart on page 328. I'm just going to put that up here briefly. This shows all the possible outcomes from rolling 2 dice. I could get a 1 and a 1, a 2 and a 1, a 3 and a 1, a 4 and a 1. I could also get a 1 and a 2, 1 and a 3. This shows all the possible outcomes. This is page 328 of your textbook. So by looking at this, the question was, what's the probability that the sum of the dots on the upward faces is divisible by 3? So what I want to look for is, what numbers are divisible by 3? Well, a sum of 3, 2 and 1 make 3. A sum of 6, okay, 5 and 1. Those add up to be 4 and 2, 3 and 3. Those add up to be 6. A sum of 9, 6 and 3, 5 and 4, 4 and 5, 3 and 6. Or a sum of 12. Double sixes right here. So I'm going to count all of those sums that are divisible by 3. That would include all the sums of 3, 6, 9, and 12. And when I count those up, I see that there are actually 12 out of a total of 36 possibilities, and that will reduce down to 1/3. So you have a 1 in 3 chance of finding the sum of dots on the upward faces that's divisible by 3. Number 38, this is a pair of Bose headphones are regularly sells for $314 is on sale for $226.08. What is that discount rate? Remember, to find the percent of change, you're going to take the amount of change, how much did it increase or how much did it decrease, and divide that by the original amount. So if I find the difference, if I subtract 314 minus 226.08, I'm going to get a change of $87.92. That's the discount. That's how much it was decreased. And I divide that by the original amount, and I will get a decimal of 0.28. I want my answer as a percent, so if I just shift that over 2 spaces, that would be 28%. So once again, to find the percent of increase or decrease, we subtract the original amount from the new amount. Okay, that's how much it's changed. And I divide that by the original amount. So that discount rate is 28%, and that was a decrease. All right, number 39. A square tile measures an 8-inch by 8-inch and it weighs 9 ounces. Find the weight in pounds of a box containing 144 tiles. One thing to be careful about here is the dimensions really are not necessary to know. This says 1 tile weighs 9 ounces. So 144 tiles are going to weigh how much? Now, one thing we got to pay attention to is this is given in ounces, and I want an answer in pounds. We'll get there. But I'm going to set up a proportion. 1 tile is 9 ounces. So 144 tiles would be how many ounces? Make sure you're careful to put the same unit on either side. Tile over ounce equals tiles over ounce. So we can cross multiply. All right, and we will get X equals 1,296 ounces. Okay. All right, and so that's my answer in ounces, but remember it wants an answer in pounds. So 1 pound is 16 ounces. If I will divide this by 16, that will give me an answer of 81 pounds. And last problem, number 45 less than the quotient of a number and 2 is equal to 3. Find that number. Be careful when a problem involves subtraction because the order that you subtract is really important. This says 5 less, so it means that I am taking 5 away from something. If it said 5 minus, then I would put 5 in front of the subtraction sign. But 5 less indicates that 5 is being subtracted from something else. And it's being taken away from the quotient. Okay, so quotient involves division. What am I dividing? A number and 2. Okay, so 5 less than the quotient of a number and 2. So something divided by 2 minus 5 is equal to 3. So that's my equation. And I'm going to find that number by solving for x. The first thing I will do is add 5 to the other side. So x divided by 2 equals 8. What's the opposite of division? Multiplication. So we'll multiply both sides by 2. And my answer will be 16. We can check that. 16 divided by 2 is 8. 8 minus 5 is 3. All right, so that is the end of our final exam review. I hope that this has been helpful. I encourage you to look back over the other Zoom sessions just to refresh your memory on any individual chapter that you've had questions about. I'll be glad to address those questions individually. If you'd like to message me, we can even communicate over the phone if that would be helpful. But I just wish you all the best on your final and as we wrap up this last week of our course.